of the immune system. The immune system is a vast majority of cells and tissue membranes that protects your body from any foreign invaders. So, there are 3 types of responses. The first one is non-specific immunity. Non-specific immunity are things that you wouldn't expect to be your part of your immune system. Your skin, which is the cover for your muscles and other things, and your mucus inside your nose. Mucus may be very stinky stuff, but it is really useful. When any antigen or foreign particle gets inhaled through your nose, that foreign particle is trapped by the mucus or the cilia. The cilia are the hair-like projections inside the opening of the nose that trap all the bacteria, leaving all the bacteria at bay. But sometimes they do manage to get through your skin and mucous membranes. Sometimes they can go into the lungs that can cause pneumonia. And sometimes they breach your skin when you get a wound. When you get a wound, the bacteria go into your bloodstream and reach parts of your body where they can start doing damage. But our bodies aren't powerless. Meet the immune system. It's an army of cells that bust off the virus before it can do any damage. So on the front line, neutrophils. Neutrophils are cells that are stockpiling in the area. They kill every part of the antigen, cells and all, and die off. That's what you see as pus in your wound. Those little bodies of the neutrophils are seen as pus. As soon as neutrophils mark a response, it stimulates the macrophage. Whoa, but wait. Who is the mastermind behind all these attacks? They are the helper T cell. Meet the helper T cell. The helper T cell is a cell that can produce hormones that stimulate neutrophils to march to the area and destroy the virus. Once the front line is come, helper T cells stimulate macrophages to come and consume the neutrophil and consume the rest of the neutrophils' bodies and the antigens. Now here come the B cell and the T cell. B cells, first T cells also go and reach the site. The T cells also gobble up the antigens and send the detail of the antigens to these B cells. These B cells, what they do is, they process the details of the antigen and mass produce allies called antibodies. Antibodies can bind to the antigen and there are 2 forms of neutralizing the bacteria. The first form is the antibodies can flag the bacteria for destruction. So the antibodies are a powerful ally along with macrophages. These little guys swallow up this virus as you see here. These guys swallow up the viruses, as you can see here. I've drawn a virus. They swallow up them up. So there are two types of macrophages. The first types are free macrophages, patrolling and scouting the blood for any foreign antigens and swallowing them. And the other ones are fixed antigens. For example, like in the liver, they crouch, they take the antibodies and swallow them with little arms they have. And the same goes to the free antibodies. So there are two types of responses. There are two types of responses for busting out the bacteria. The cell-mediated response and the humoral response. Cell-mediated response uses these. Yeah, that's right. Cytotoxic T cells. The cytotoxic T cells, once verify that the cell is containing the virus or bacteria that the person is infected with, once sensing that, release a hormone that triggers apoptosis. There's a hormone that they produce in the outer projections. When cells become cancerous or they have the virus replication code and are just about to replicate, the cytotoxic T cell pokes a hole in the cell wall and triggers natural cell death or apoptosis. So now this is the humoral response, which uses both neutrophils and macrophages. And also these B and T cells. The humoral response is when a B cell stops to see, is when these B cells stop to see an antigen which is floating mid-air in the body. This antigen is sensed by the B cells, but they can't do it without a stimuli. And as I told you before in this topic, it needs the helper T cells. The helper T cells release the hormone that activates the B cells. This B cell activation kills the bacteria. So, what happens if this infects you in future? There are these memory and B cells and memory T cells to help. The memory B cells and T cells keep a note of the intruder and then when it attacks in the future, it gets all the cell responses ready to neutralize it. There are antibiotics, antivirals and vaccines to help strengthen this response. Antibiotics, as you know, are put when you get a bacterial infection. When these are consumed, the antibiotics can kill the bacteria. As you know, your cells have experienced pathogens of lots of types, and memory B cells and T cells can't just make a note of everything. Sometimes they have too much to do. So antibiotics help them. So when the antibiotics come, they just poke a hole in the cell wall, like for cancerous cells. These cytotoxic T cells poke the hole in the cells, but this is a different cell, totally different cell, bacteria. It pokes the hole in and it triggers cell death in bacteria. Now vaccines are a once for all fishing learning. how to fish learning. As they say, if you give a man fish, they'll only eat for one time. If you teach a man how to fish, he'll eat for his life. The same way vaccines teach the immune cells to recognize the same thing given in either in weekend, only one antigen, given in a weekend dead, or only one antigen form. And vaccines with the weekend antibodies are called live vaccines. If you want to make a vaccine, you should not trigger your body's response. You should not release the full-fledged virus. So, doctors always find a weaker cousin of the virus and inject it into the live vaccine. So now, as soon as this is recognized, the memory B and T cells get to work. They take a copy of the weakened antigen and place it in the memory cells for later use. The next time, if that pathogen attacks, it can bust it off. Antivirals, though, on the other hand, work for a totally different purpose. Even if you take antibiotics for a viral infection, after some days, when infections actually cure, you feel more sick than usual. It's because it's a common myth that antibiotics can kill viruses. This myth is busted for now because doctors tell that antibiotics can't kill bacteria because, as I told before, bacteria bust the cell wall and trigger apoptosis. But for viruses, though, it's a different story. You may be thinking that the protein coat is the cell wall, but it's not. Protein coat is just a coat of protein. So when antibiotics try to kill and poke a hole in the cell wall, it won't, because the protein coat is resistant to antibiotics, because basically antibiotics don't work here. Yeah, we know all that. So basically antibiotics don't work. You need other medications called antivirals for this. Antivirals destroy the cell, activate both the cell-mediated and human response. But instead of cytotoxic T cells, neutrophils and macrophages, the antivirals do the job of these things. The antivirals trigger the cell-mediated response by poking a hole and triggering cell death in virus-infected cells. And also sometimes doctors can apply medication that can attach to the projections on the virus. Those are like protein key and lock. Those are like protein keys for the virus to enter inside. So that medicine coats those protein keys so they don't bind as much to your cell's walls. The human response is when the antivirals destroy the outer coating and then they remove the protein coat and destroy the DNA layer by layer. So this is all doctors can do to protect you. These medications can also be delivered in IV, pill and injection form. This is all doctors can do, can help you. You can't be sitting with an IV all lifelong with a disease. You can't be sitting with an IV, and you can't go to the doctor daily to get to get shots of drugs, and you can't take doses of pills daily. So that's all doctors can do to help you. But it's up to you to protect yourself. Your natural medications are basically food. Things like gooseberries are rich in vitamins A and C. And A and C can improve all these cells' hard work and efficiency. So it's up to you to protect your immune system, and it's up to your immune system and your to protect you. And also antibiotics help a little when your immune system can't work so effectively. So your role, your immune system's role, and antibiotics don't go hand in hand. We should not disrupt these roles for any reason by taking foods that disrupt the function of immune cells. I say for the last time, your immune system is a precious vial of lymph nodes that can never be beaten by others. Thank you.